Hi, this is Teacher Jor. Good day everyone! Today we are going to tackle about limit theorems and we will solely focus on the product rule and difference rule. So, bear with me guys and enjoy learning! So, let us begin with our theorem number 5, the product rule. So by definition, like addition and subtraction laws, this particular limit law states that the limit of the product of two functions is equal to the product of each function's corresponding limits. So suppose we are given two functions that is separated by the multiplication as its operations. So suppose we have the limit of f of x as x approaches 3 is equal to L, or the limit of this given function, and the limit of g of x as x approaches 3 equals m, and then the limit of f of x multiplied to the limit of g of x as x approaches a is equal to L times m. So basically, we have to separately treat the limit of each function and then proceed to multiplication. Okay, so to understand more, let me give you an example. So example number 1. We have the limit of x times 6x minus 2 as x approaches 3. So we have to separately get their limit. It will look like this. The limit of x as x approaches 3 times the limit of 6x minus 2 as x approaches 3. Notice that our second term, or our g of x, we can proceed to getting its limit because we have to break it down and simplify in order to get its value. So our first term, the limit of x as x approaches 3, we can directly get its limit by using the identity rule. Okay, so what rule or what theorem should we use for our second limit, for our second function? By our previous theorems, we have to use the difference rule. Okay, so it will look like this. The limit of x as x approaches 3 times the limit of 6x as x approaches 3 minus the limit of 2 as x approaches 3. Okay, notice that our first term, the limit of this is equal to 3, while our second term, the limit of 6x as x approaches 3, we have to use the constant multiple rule, and the last term, we have to use constant rule. So 3 times 6 and the limit of x as x approaches 3 minus the limit of 2 as x approaches 3. So it will become 3 times 6 times 3 minus 2. It is 3 because the limit of x as x approaches 3 is equal to 3 minus 2 because we have to incorporate the constant rule. So let us first simplify the numbers that are in the bracket. So 6 times 3 is equal to 18 minus 2, that's 16. So 3 times 16 is equal to 48. So by using the product rule, the limit of x times 6x minus 2 as x approaches 3 is equal to 48. So have you noticed that we have incorporated a lot of theorems or a lot of rules? So it is very necessary to learn first the basic theorems in order to level it up. We have in this given example, we have used the difference rule, the identity rule, and the constant rule. Okay, so that's our product theorem. Now let us proceed to our quotient rule. So theorem number 6, or the quotient rule. So this means that the limit of the quotient of two functions is equivalent to the ratio of each of the function's limits. But we have to take note that this law is only applicable when the limit of g of x as x approaches a is not equal to 0. So take note that it has its condition. If we say g of x, this means this is the number or the function that is in our denominator. So suppose we have the limit of f of x as x approaches a equal to L, and the limit of g of x as x approaches a equals m. And then If we use the quotient rule, then it will look like this. The limit of f of x all over g of x as x approaches a is equal to L over m, provided that our m or our denominator is not equal to 0. So, how can we identify or determine if our g of x is equal to 0 or not? Okay, so in order to clarify that thought, then I'll give you an example. Here, example, the limit of x all over x minus 4 as x approaches negative 2. So, by definition, we have first to check if our denominator or the g of x it will be equated to 0 or not. So, in order to identify that or in order to check that, then we have to use the value of our x and substitute it to the function. And in this case, the value of our x is negative 2. So, if I ask you, if we substitute negative 2 to our denominator, the x minus 4, will L equate to 0 or not? Okay, so it is very clear that it will not equate to 0. The answer would be negative 6. So we have satisfied that condition. Then now we can proceed to using the quotient rule, because if our denominator will become 0, then we can't get its limit because that function will be undefined. Okay, we have to take note of that. So okay, after knowing that we can proceed to using the quotient rule, then we proceed to breaking down our function. So we have first to get the limit of our numerator, the limit of x as x approaches negative 2 all over the limit of x minus 4 as x approaches negative 2. So just like our previous example, notice that our denominator, we can't get its limit directly. We have to break it down, and that is by using again the difference rule. Okay, so here, the limit of x as x approaches negative 2 by using the identity rule, that is equal to negative 2. Hence, the negative 2 as our numerator all over the limit of x as x approaches negative 2 minus the limit of 4 as x approaches negative 2. So now we can simplify our denominator by using the identity rule and constant rule. So, negative 2 all over the negative 2, because the limit of x as x approaches negative 2 by using identity rule, it is equal to negative 2 minus the limit of 4 as x approaches negative 2 by using constant rule, that is equal to negative 4. So, negative 2 all over negative 6, and the answer would be 1/3. So, it is 1/3. It is a positive number, since if we divide numbers with the same sign, then the answer would be always positive. Hence, the limit of x all over x minus 4 as x approaches negative 2 is equal to 1/3. So that is how we use our quotient rule. So we have to remember, as a summary in our product rule, we have to remember that if we have two functions that is separated by multiplication as its operation, then we have to use the product rule and apply the necessary theorems. While in the quotient rule, we have to take note that we have to check first if our denominator equates to 0 or not, and we can do that by substituting the value of our x to our given function. And in this example, we can say that it will not equate to 0. That's why we can proceed to using the quotient rule. But otherwise, you can proceed to using it because it will be undefined. And that's it. I hope you have learned how to evaluate the limit of a function by using the limit theorems, specifically the product rule and quotient rule. So, see you in our next video. Bye!